I've included this example because it's a little bit different in that the way it's presented, just to solve x plus 6 greater than or equal to x squared. So when you read that for the first time, you might be going, oh, x plus 6 is a straight line. Is this linear? Is greater than, oh, no, it's not greater than or equal to 0, and it's got an x squared there. Well, to be honest, there's a couple of ways you could do that, but for now, I'm just going to treat this as a quadratic inequality. And I'm going to say, well, let's rewrite it in this format, and hopefully you can see where that came from. So all I've done is taken the x squared to the left-hand side and sat it here, plus x plus 6 is now greater than or equal to 0. And my understanding is I'm now looking for where the parabola and the fact that it's got a minus in front of the x squared is it's an upside down parabola. Where is this parabola greater than or equal to 0? That as a region greater than or equal to 0, remember, was above the x-axis. So if I now go and put in my x-axis, I want to know where is the parabola above or on the x-axis. So I clearly want this region. Let me see if I can colour that. And that shouldn't be below that black line. And I need to identify the x values that will place the parabola up here above the axis. So now we set about drawing the graph of y equals minus x squared plus x plus 6. So that's our first step. Draw this graph. We want to know where the graph is above the x-axis, and in particular, what x values put the graph above the x-axis. You can probably see that our solution is going to be a continuous one again. So we'll go continuously from this x value to this x value. So we really should be able to write our solution, and it'll have an equal sign, in this format. We're yet to just identify what these two numbers are. So they actually work out to be the intercepts. So we need to solve. To find the intercepts, we'll solve. Minus x squared plus x plus 6 is equal to 0. I would do that, probably the easiest is to swap sides and do x squared minus x minus 6. So we're looking for two numbers that multiply to give minus 6 and add to give minus 1, which will be a minus 3 and a plus 2. Gives minus 6, adds to minus 1. Therefore, we've got that they're equal to 0. Therefore, x must be minus 2 and 3. So at minus 2 and at 3, our parabola is upside down, and that's all we're concerned about for the moment. We're not really concerned about where the axis of symmetry is, what the maximum value is. We're not interested in any of that. All that we're being asked to do is to solve, which means find the x values where this would be true. So we end up with, therefore, x is greater than or equal to -2, less than or equal to 3. I started the video off by saying there are various ways you could actually do this question, and another way that you could do it graphically, but I won't go into the full detail, is you could read this as find the x values where this function, which is y equals x plus 6, which we know is a straight line, cuts at 6, what's the range of x values such that that straight line is greater than or equal to the parabola? And we know that a parabola y equals x squared sits here like this. So this one is our y equals x squared, and this one is our straight line. Where are the x values where the straight line is bigger or above the parabola? Well, it is only a bit above the parabola in these sections. Otherwise, then the parabola goes above the straight line. So we actually want the x values from here to here. Now, that's quite a different solution, and you would actually need to work out the points of intersection. You'd have to actually solve x plus 6 equals x squared. And when you solve that, you'll actually find you're getting the same sort of solution as over here. You'll identify your -2, you'll identify your 3, and you'll say in the range between -2 and 3, the straight line was higher than the parabola. I wouldn't encourage you to do it via this particular method. However, it's good to talk about it because there will be some graphs where this is the method that you will use, graphing the two separate functions and seeing whatever the inequality suggests, a greater than or a less than, where one particular function is compared to the other one. So here on the next page is the graph, just in case you didn't get it, and the actual solution. You should be fairly right to work on exercise 3A. I haven't asked you to do any of that for homework, and that's fine. If you do want to get started, you have the time. You might want to do something out of questions 1 and 2 and possibly 3, but there is no requirement for you to do that. We will look at those in class.